components. Welcome back to Angular Component Communication from Pluralsight. My name is Deborah Kurata, and in these next 3 modules, we examine techniques for communicating through a service. Sometimes we need a component to talk to itself. Well, not quite like that. Other times we need a component to talk to its peers. Well, not quite like that either. How does a service help a component talk to itself or its peers? In this context, we can think of a service as a box. A component can put something into the box and get it out later, thereby communicating that information to itself. Why would we want to do that? We'll answer that question in this module. We can also use a service to communicate between multiple components. A component can drop a value into the box, and any other components can retrieve or update that value. Bottom line, we use a service as a mechanism for storing data, or state, thereby communicating that state with other components. In this module, we look at what state means and several techniques for managing state in an application. We then examine how to set up a service as a property bag. A component can use that property bag to communicate with itself or any other component in the application. Lastly, we look at service scope and lifetime, which affects which components can access the service and when. Let's get started. What is state in this context? Well, it can be information about the view, such as whether to display images or the user-entered filter string. It can be user information, such as the user's name and roles, that is used to tailor the application for the user. State can be entity data, such as our product information, that is displayed and manipulated by the application, but originally retrieved from and stored on a back-end server somewhere. It can be user selection and input, such as the currently selected product or edited product name, or any other information or data that the application tracks. There are many techniques available for managing state in an application. At the low end of the complexity scale is a property bag. We define a service that exposes simple properties that our components use to communicate state amongst themselves. We can think of services such as these as property bags, as they are just bags of properties with no real logic or state management. Moving up the complexity scale, we define a basic state management service that retrieves, manipulates, inserts, deletes, and stores application state. Our components use this service to share entity state and communicate state changes using Angular's built-in change detection. Taking it up another notch on the complexity scale, we add notifications using subject, behavior subject, or similar. What are subjects? We'll cover that a little later in this course. For now, we can think of them as a way to provide notifications when we can't leverage Angular's built-in change detection to communicate state changes. At the top of the scale is NGRX, which is a powerful state management library inspired by Redux. It is based on 4 core tenets. State is a single immutable data structure. Actions describe state changes. Pure functions, or reducers, take the current state and next action to produce a new state. And state is accessed with a store, which is an observable of the state and an observer of all actions. NGRX provides a well-defined pattern and techniques for handling complex state throughout an application, but it requires a lot of configuration and plumbing, which can result in a large amount of additional code to create and maintain. This module covers the first technique. The next 2 modules cover these 2. To keep the course focused on component communication, this course does not cover the big topics of NGRX or Redux. Check the Pluralsight library for courses on these topics. For each bit of application state, we can use the technique that is as simple or as complex as needed for the application's requirements. Sometimes a component needs to communicate with itself, and it can do so using a service. Why would it ever need to communicate with itself? Let's walk through an example. Here is the product list page. Let's filter to only those products containing the text ME and show the images. Now that we have our criteria settings just like we want them, let's view the detail of one of the pages. Looks good. Returning back to the product list page, and we've lost all of our criteria selections. Bummer. Why is that? When the user makes selections, we store those selections in the component's property. If the user then navigates away from that component, the component is destroyed and its component property values are lost. The navigated component is then initialized and displayed. When the user returns to the original component, it is reinitialized and displayed, and it has no memory of the user's selections. Gone. What we need is a way for the component to stash away its view state somewhere so it can get that state back each time the component is redisplayed. We do that by creating a service. In the service, we define a property for each bit of state that the component wants to track. In our example, we want to track whether or not to display the image and the user-entered filter by value. We can think of the service then as holding a bag of property values. So this type of service is sometimes called a property bag. As the user works with the page, we use setters to store the values in the service properties instead of in local backing variables. That way the values are retained even when the component is destroyed. Each time the user modifies the filter by value, the binding calls the list filter setter, which in turn sets the property value in the service. When the user clicks the Show Image button, the binding calls the Show Image setter, which in turn sets the property value in the service. If the user then navigates to the product detail component, the product list component is destroyed, but the service lives on. When the user returns to the product list component, the binding calls the list filter getter, which retrieves the value from the service and applies the setting. And it calls the show image getter, which retrieves and applies that value from the service. Bottom line, a component cannot remember its property values once the user navigates away, because the component and all of its state is destroyed. So we build a service to retain those values. Let's look at how to build a property bag style service. An Angular service is a class that can provide functionality above and beyond our components. We can build a service to provide cross-cutting tasks such as logging, perform operations such as calculations or business logic, encapsulate functionality such as data access, or share data beyond the lifetime of a component or across components. When we create a service, we register its provider with an Angular injector. We can then inject the service into any component that needs it. By default, services are basically singletons, which means that Angular maintains a single instance of the service. That way, if we set service properties, any component that injects the service can access those property values. Now let's jump into a demo and start building this service. We are back in VS Code with the APM sample application open. Let's remind ourselves how the application works now. If the application is not currently running, type npm start, and the application is opened in the browser. Click on Product List, and the list of products appears. Let's filter the list by ME, and notice how our list correctly filters the results. Yay! And if we click the Show Image button, the product images appear. Click on one of the products to view the detail, return back to the product list, and our selections are gone. Let's fix this by building a new property bag service. Back in the code, let's use the Angular CLI to create our new service. I'll open a new terminal window using the plus sign here. At the command prompt, type ng for the Angular CLI, G for generate, S for service, products/product-parameter to define the folder and file name for the service. And let's add -m product/product.module, so the CLI will automatically register the service in the product module. We'll talk more about service registration at the end of this course module. And we see that the CLI created 2 new files and updated our module. Opening the product module, we see that the CLI added our new service to the providers array. Now let's open our new product parameter service and add the properties that we want to track. I'll close the terminal so we have more space. We want one property to hold whether or not the product list component should show its image, and one property to hold the user entered filtered by string. And that's it. To build a service whose sole purpose is to be a property bag, all we need to do is define the properties. We could add any other properties here that we want to track, but these 2 are enough for our purposes. Next, let's open the product list component and modify it to use our new service. First, we inject the service into this component using the constructor. Then use the quick fix to add the associated import statement. Now we can access the service properties. Let's start with show image. We'll delete the simple properties statement and instead create a getter and setter, but with no backing variable. We don't need a backing variable because we'll instead store the value in the service. In the getter, we get the value from the service. In the setter, we set the value into the service. Let's try out what we have so far. In the browser, on the product list page, we'll select to show the product images. Navigate to the details for one of the products, click back to return, and it remembered our image setting. Yes! Now, what about our filter? The filter is a bit more complex now because we no longer have a list filter property in our component. Recall from the last module that we moved the filter by functionality into a child component. Looking back at the code, instead of a simple setter here in our product list component, the product list component needs to track changes to the filter by in the child component. This is actually easier than it sounds because we already receive change notifications. In the product list template, we receive an event notification from the child component each time the filter by value changes. The event binding calls our onValueChange method. We defined that method earlier in this course to perform our filter. It is here that we can set the filter value into the service. Now we just need to get the value from the service to use it as a default. Instead of a simple getter, we need to obtain a reference to the child component. Then we can use that reference to assign a default value to the filter by. Recall from earlier in this course that we can get a reference to the child component using the viewChild decorator. We specify the viewChild decorator and pass in the name of the child component, which we called criteria component. We then specify a property name to hold the reference to the child component. Let's call it filter component, and its type is criteria component. We'll use the quick fix to add the appropriate import statement. Now, where should we get the service value and use it to set the filter by default? In the ng-on init, we retrieve the products, and in the callback, we perform the initial filter. Let's set the filter by default there. We use the reference to the child component, this .filter component. Notice that IntelliSense provides us with a list of all of the properties and methods that we can access. We want to set the list filter property. We assign it to the product parameter service property value. Setting the child component's list filter property causes the child component to emit a change event that the product list template catches and calls the onValueChange method. Since we are performing the filter here, we don't need to do it in the callback as well, so we can delete this line. Let's give it a try. We'll again filter the list by ME, and notice how our list correctly filters the results. Click the Show Image button, and the product images appear. Click on one of the products to view the detail, return back to the product list, and our selections are retained. It even set the correct filter by default. It works. We now have a property bag service for a component to communicate with itself. Can we use this technique to communicate between components? Yes, we can. We've just seen how to build a service as a property bag to hold a set of properties. A component can stash away values into these properties and retrieve them later. Our service then provides a way for a component to communicate with its future self. We can also use a property bag type of service to communicate between components. For example, if we had an advanced search component, it could set values into service properties based on user entries. The list component could read these properties and filter accordingly. In this example, our service provides an intermediary for communication between the search component and the list component. Build a service as a property bag anytime a component needs to stash away some property values for itself or for communication with another component. Before we move on, let's take a moment to talk about service scope and lifetime. When we create a service, we register it by adding the service to the provider's array of a component or of a module. Which do we use when? Where we register the service defines the service scope and lifetime. The service scope determines which components can see and access the service. If we want to ensure all components can access a service or prevent access except by a few components, we need to carefully consider where we register the service. The registration location also affects the service lifetime. That lifetime is crucial if we are using a service to retain property values or share state. Let's look at registering a service in a component first. Then we'll look at registering it in a module. When we register a service in a component, the service is accessible to that component and all of its children. What do we mean by children in this context? We mean any components that are specified within the component's template or are routed into the component's router outlet. As an example, let's look at the component hierarchy of our APM application. As with most Angular applications, the root application component is the app component. Recall that in our example, the root app component contains only a router outlet. In that router outlet, we can route to the shell component or login component. The shell component contains another router outlet. In that outlet, we route to the product list, product detail, or product edit components. The product list component contains both the criteria and star child components, and the product detail component contains the star child component. So this is a simple view of our component hierarchy. If we register a service, such as our product parameter service, in the root app component, the service is accessible to it and every component under it in the component hierarchy. And since the app component is our bootstrap component, the registered service is retained for the lifetime of the application. If we register a service in the shell component, it is accessible to it and every component under it in the component hierarchy, but not the app component nor the login component, and it means that the service is retained only while the shell component is loaded. If we move the registration into the product list component, it is available to it and each of its children, but not the other product components, and it means that the service is retained only while the product list component is loaded. Registering our product parameter service in the product list component would seem to make sense, because only the product list component needs it. But if the user navigates to the product detail, the product list component is destroyed along with the service instance. What happens if we register the service in both the product list component and the product detail component? We get two different instances of the service. We won't be able to share data or communicate through the service, and each instance of the service is destroyed when its associated component is destroyed. But multiple instances of a service are not always a bad thing. Say that we want to display multiple product list components on a single page, maybe one for in-stock products and one for out-of-stock products. We may want separate instances of the Product Data Access Service, one for each displayed product list component, so they can each retain their own list of products. By registering the Product Data Access Service with the product list component, each instance of the product list component gets its own instance of the service. The bottom line here is that we need to consider both our desired service scope and lifetime when selecting to register a service in a component. If you want to try out the effect of component registration using the sample application or one of your own applications, you can instrument a service to monitor its lifetime using code such as this. Use the constructor to examine when the service instance is created, and implement onDestroy to monitor when the service instance is destroyed. Feel free to use the product parameter service and experiment with registering services at different levels of the component hierarchy. If we register a service in a module instead of a component, we don't have these issues. Regardless of the module we register the service in, the service is registered in the application's root, so it is accessible to every component in the application for the lifetime of the application. However, if the module is lazy loaded, the story is a bit different. Services registered in a lazy loaded module are only available to components declared within that module. Once the module is loaded, the service is available for the lifetime of the application. Now let's finish up this course module with some guidelines for using the communication mechanisms we've covered. With every technique, there are rules for its usage. Well, not really rules, more what you'd call guidelines than actual rules. Use a property bag service as a mechanism for a component to communicate with its future self. In this capacity, a property bag service is great for retaining view state or user selections. A component sets values in the service to retain its state, so when the user navigates to another component, the state is not lost. When the user returns to the original component, that component reads the values from the service to return it to its prior state. Note, however, that any component that has access to the service can easily read or change any of the property values. This may not be an issue if the application is a manageable size, and care is taken not to inject the service into any component that should not access or modify the service properties. We can also use a property bag service as a mechanism for components to communicate amongst themselves. It provides an easy way for a set of components to share property values. And if the properties are bound in a template, Angular's built-in change detection automatically communicates state changes and updates the views accordingly. We'll talk more about change detection in the next module. And again, note that any component that has access to the service can read or change any property. Also, components are only notified of state changes if the properties are bound in the template. We'll look at generating explicit change notifications from our services later in this course. It is important to consider the required scope and lifetime of a service when deciding where to register that service. Register a service with a module or the root application component to ensure that the service is available to all components for the lifetime of the application. Note that service registration in a module works a bit differently if the module is lazy loaded. Services registered in a lazy loaded module are only available to any components defined within that module. They are still available for the lifetime of the application. If you wish to limit which components can access a service, define the service in the correct location in the application's component hierarchy. But be aware of how your choice affects the lifetime of the service. If the user can navigate away from the component, the service instance is destroyed along with any state it was retaining. On the plus side, we can register a service in a specific component if we want multiple instances of the service, one for each instance of the component. This is useful if you need the component displayed multiple times on the view, and each needs its own unique instance of the service. In this module, we first looked at state, what it is, and several state management techniques. Then we built a property bag service. Our component used that service to communicate with its future self. We can also use a property bag service to communicate between components, and we discuss the importance of carefully selecting where a service is registered. The registration location determines the service scope and lifetime. Here again is our diagram of increasingly complex techniques for managing state as a communication mechanism. We just covered the simplest option, building a property bag service to retain and share a set of property values. Next, let's build a basic state management service. Sometimes we need a service to be more than a bag of properties. We need it to retrieve, manage, store, and share our application state. Welcome back to Angular Component Communication from Pluralsight. My name is Deborah Kurata, and in this module we build a basic state management service. Communication is all about sharing. A service shares state information to communicate that information to the components of the application. Recall from the prior module that we identified several techniques for managing and sharing state. Then we examined a property bag service and how to use it to retain state in a set of properties. Now we'll move up the complexity scale and work through a basic state management service. In this module, we build a basic state management service. With it, we share entity state, such as products, throughout the application. Then we look at an alternative user interface design that displays multiple concurrent components and examine a simple yet often overlooked mechanism for keeping the state of these components in sync. Then we take a brief look at Angular's change detection and how it communicates changes to that state. Let's get started. Most applications deal with some entity data, such as movies or posts or financial transactions or products. These applications retrieve that data from somewhere, work with it as needed, and store any changes back. We often build a data access service to encapsulate these operations, using HTTP to contact the appropriate backend server. A data access service often has methods to get all or some subset of entities, get a particular entity by ID, and create, delete, or update an entity. We could set up our application such that each component uses the data access service as a pass-through to get the data it needs from the backend server. For example, as our sample application is now, each component gets its own data from the backend server. The product list component calls the getProducts method, which in turn calls the HTTP get method to get the list of products from the backend server. If the user navigates to a particular product, the product detail component uses the getProduct method, which calls the HTTP get method to re-get the product from the backend server. It does not take advantage of the data that was already retrieved. And when the user navigates back to the product list component, that data is retrieved again using the getProducts method. Now, there may be times that the application must always get the freshest data. For example, if we were building a reservation system, we would always want to show current availability. If we were building a stock market application, we would always want to show the current market prices. But for many scenarios, such as this list of products, the data just doesn't change that often, so there is no real need to re-get the data every time. We could instead modify the service to retrieve the entity data once when a component first requests it, and then share that data with any component that needs it. To accomplish this goal, we change the data access service to be more of a state management service that holds onto, manages, and shares the state of our entities. The first time a component requests a list of entities, the state management service gets the data from the backend server and stores the list in a property. We can think of that property as a data cache. Then every other time a component requests the entities, the state management service returns the pre-retrieved list. And every time a component requests a single entity, the state management service finds that item in the list of pre-retrieved entities. This can dramatically reduce the number of times we contact the backend server. Before we jump into building this state management service, let's take a quick look at our current data access service. We are back in the APM sample application with the product service open. The product service provides methods to get data from and save data to a backend server. Looking at our app module, we are using an in-memory web API as our backend server. That way, you can work with this code without installing an actual backend server. But this also means that any changes to the data that we make when running the application are only retained when the application is loaded. Anytime the application is refreshed, the in-memory web API reloads the original set of hard-coded products. Going back to the service, here is the URL to that server. The getProducts method retrieves the list of products. We walk through the basics of this method in other Pluralsight courses, such as Angular Getting Started and Angular Reactive Forms. If this observable operator syntax looks new to you, it was introduced in RxJS 5.5. Starting in version 5.5, RxJS includes lettable operators, sometimes called pipeable operators. These operators are imported from RxJS operators, and notice they have a much more normal-looking import statement. But these new pipeable operators no longer support the dot chaining of a fluid syntax. Instead, we use the observable pipe method to perform multiple operations. And because the operators are now independent of observable, they could not conflict with JavaScript keywords. So the do operator you may have seen before is now tap, to tap into the observable without modifying it. And the catch is now catch error. Here is the getProduct method that retrieves a single product by ID. And we have the remaining CRUD operations, create, update, and delete. Note that our publicly facing SaveProduct method calls the appropriate create or update operation based on whether the product has an existing ID. Now let's morph this existing data access service into a state management service. The purpose of a state management service is to provide state values, maintain and update state, and observe changes to that state. To turn a basic data access service into a state management service, we need to add a property to retain the list of entities. This property is populated the first time we retrieve the data, and any other requests for the data use this property. On a get, we then return that list if it's already been retrieved. On a get by ID, we locate and return the requested item from that list. Since we use the retained list as the source of entity data in the application, we'll need to keep that list updated as the user creates or deletes items. On a create, we not only save the new item to the backend server, but we also add the item to that list. Similarly, on a delete, we delete the item from the backend server and remove the item from that list. That way our retained list always shows the appropriate items. Note that the retained list will not include any changes made by any other user because it does not go to the database to get the current list of items. If having current data is a critical scenario for your application, you may not want to retain entity state and instead continue to use the data access service as it is. Or minimally, consider getting the item directly from the backend server when the user selects an edit operation to ensure they are always editing the item's current values. Optionally, we could add code to track the time and expire the retained list after a predefined amount of time. This is important to prevent stale data. Now let's jump into a demo and perform these steps to change our data access service into a state management service. We can build a state management service to manage any application state. The service then shares that state with the components of the application by providing features to retrieve and maintain that state. Let's look at the retrieve features first. Back in our APM application, for our particular scenario, let's assume that the list of products that our company sells does not change very often. We can then improve performance of our application by changing our data access service to a state management service. We start by adding a property to retain the list of products. We'll make it private so that any code that uses this service gets the data through a get method. We'll call the property products, and its type is iProductArray. In the getProducts method, we add code to check this new property. If the property is set, we return its pre-retrieved list of products. Since this method is expecting to return an observable, we use the observable of operator to create an observable from our products array. If the products array is not yet set, the existing code uses HTTP to get the data from the backend server. The existing code uses the observable pipe method to pipe the return data through a set of observable operators. First, we use the tap operator to display the return data to the console. The tap operator allows us to tap in to the observable and defines an action to take that does not modify the observable stream. Logging the result helps us see when the data is retrieved from the backend server. You may have noticed the result of this logging throughout this course. Is there something else we need to do here? Yes, there is. We need to set our new products property to the returned array of products. Since setting our property does not modify the observable stream, we can again use the tap operator. We could change this tap operator to a multi-line function and perform both operations here. But let's just add a second tap operator. That way we could more easily modify or delete this debugging code. In the fat arrow function, we simply assign our product's property to the returned data. Now, when we get the products the first time, we'll retain those values to share throughout the application. We could add another property to this service to track the time and include a time check here to expire the product list if it is past its expiry date, but this is fine for our purposes. Let's see if what we've done so far works. In the browser, use the developer tools to view the console. Navigate to the product list page, and we see that the data is retrieved and logged. Click a product to view the detail and return back to the product list page. Note that the page appeared a bit quicker than before. That's because we are using the pre-retrieve list of products. Notice also that we don't have another set of data logged to the console. We're not re-retrieving the data. So far, so good. We are still, however, re-getting the data each time we display a detail view. So let's fix that next. Back in the code, now that we are retaining a cache of our products, we can use that list when the user requests to view product detail or to retrieve an item to edit. The getProduct method retrieves one product by ID. The existing code here first checks for an ID of 0. We use an ID of 0 to indicate a new product. In that case, we still want to return an initialized product, so this code is okay as it is. But if the ID is any other value, we want to retrieve the desired product from our cached list. I'll paste the code and we can walk through it. This code first ensures that we have the list of products. If so, we find the defined products using the array find method. The find method finds the first element that matches the defined criteria, which in our case is a product ID matching the passed in ID. If we find the item, we return it, again using the of operator to create an observable from our item. If we don't find the item, we fall through and get the item from the backend server using HTTP GET. Notice that we log the data to the console so we can see when the data is retrieved. If all is working well, we should never see this logged message. Let's try it out. In the browser, refresh the product list page. This reloads the application, so as expected, the list of products is re-retrieved from the backend server and displayed here in the console. Click a product to view its detail. Notice that the detail view now displays more quickly, and no additional product data appears in the console. So no additional HTTP request was executed. It works. Looking back at the code, our service is now retaining the list of products and sharing that list with any component that requests it. But what about create, update, or delete operations? How do we keep our list updated as the user makes changes? So far, we've set up our state management service to retain application state and share that state with our components. But we also need to maintain that state as the user creates, updates, or deletes state data. Let's jump right back into the demo and see how it's done. A user may want to create a new product, update an existing product, or delete a product. We need to ensure our cached list reflects these operations. Let's see how the operations work now without any changes to our service. Bringing up the browser, let's close the developer tools for more space. Let's start with an edit. We'll change the name to long-handled leaf rake. Click Save, and our updated item appears in the list. Excellent, and with no other modifications to our code. How about adding a product? We'll add a shovel, give it a product code, and save. Our new product is not on the list. Any idea why the edit worked and the add didn't? Looking at the code, when we retrieve an item for edit, we are retrieving the item from our retained list of products. We return that item by reference, so when the item is edited, it is editing that item in the list, and our edit works as expected. But when the user creates an item, we return a newly initialized product. And when the user selects to save, the create product method posts the new item to the backend server, but does not add it to the retained list of products. Let's fix that. We need to add the created item to our retained list of products. But where? We could add the code here before the return statement, but then we are directly adding the new item to our list instead of first posting the item and adding the returned item to the list. There are two possible issues with that approach. First, it would then be possible to add the new item to our list even if the post operation fails. That would not be good. Second, we may be updating some of the property values on the server, such as assigning a new product ID or setting an update date. We instead want to add the product returned from the server to our retained list of products. So we'll add the code here after we post the product to the backend server and the created item is returned. We'll again use the tap operator to perform our operation and call the array push method to push the new item onto the products array. You may be wondering why we are setting the product ID to null here. That's because the in-memory web API that we are using as the backend server requires an ID of null for it to assign a new ID. It then automatically assigns the product ID to the next available ID. Let's try it out in the browser. Notice that the change we made to the leaf rake is gone. That's because the in-memory web API that we are using for our backend server refreshes the data from our hard-coded set of initial data every time we refresh the application. That won't be the case with a real backend server. Click Add Product and create the same product, a shovel with a product code. Click Save, and our new product is on the list. It's working. Looking back at the code, we have a similar issue with the delete. We need to remove the product from the list when the item is deleted from the backend server. Where would we put that code? If you said within the pipe method as part of a tap operator, you are correct. I'll paste the code and we can talk through it. To remove the item, we first find it by index using the array findIndex method. If the item is found, the index is greater than -1, so we use the array splice method to remove the one item found at that index. Checking it out in the browser, we can see our newly created item is gone. That's again because of the in-memory web API. To try out the delete, click on the Edit button for one of the rows, then click Delete. Confirm the deletion, and our deleted product is correctly removed from the list. Yay! Going back to the code, we now have an operational, but basic, state management service we can use to share entity state between the components of our application. With our current user interface design, we only display one primary component at a time. So even though we are sharing data using the state management service, we aren't really using it for direct communication between components of the application. Let's modify our design to display multiple components at the same time and see how to keep their view state in sync. Let's consider a different style of design for our user interface. Often users want a list of possible items on the left. Selecting an item displays the details on the right. Looks nice. With this design, the list component on the left needs to signal to the detail component on the right when it's time to display a different product. Let's break down this new UI. There is an outer product shell component here that contains the two sibling components, the product shell list component on the left and the product shell detail component on the right. Since this is a course on component communication, I want us to focus on how to communicate between components without spending a lot of time creating these components and their associated templates. So I pre-built the 3 components for this user interface. Let's take a look at these components and add the code required for the component on the left to notify the component on the right when the user has selected a product. Back in the demo application, you can find the components for this new UI under the Products folder in the Product Shell folder. Here is the Product Shell component. In the HTML, you can see that it displays the Product Shell list and Product Shell detail components as child components. It uses the Bootstrap styling classes to lay them out side by side. The Product Shell list template uses an ng4 to display the list of products with their product codes. Each product is displayed in a button, so the user can click on it to select the product. The Product Shell detail template displays the detail for a product, similar to our other product detail component. To hook up this new Product Shell, let's open the Product module. First, we add these 3 components to the declarations array: Product Shell component, Product Shell list component, Product Shell detail component. Then we add the appropriate import statement for each. In the route configuration, we'll change the path for the default route from the product list component to the Product Shell component. This will display our new user interface. Since the list and detail components are child components in this new Product Shell component, the list and the detail don't use routing, and this routing path won't be executed. We could remove it, but I'll leave it here so we can easily change back to the original user interface design later. Checking it out in the browser, click on Product List, and here is the left part of our new user interface. But clicking on an item does not display the detail. We need to provide some way for this left side list component to communicate the selected product to the detail component so it will appear on the right. When we display multiple concurrent components in a view, we often need to keep their view state in sync. For example, a user selection in one component may need to be synchronized with other displayed components. Let's take a look at one of the best, but often neglected, ways to keep state in sync between components. As we discovered in the last module, one way to provide communication between 2 components is with a property in a service. In this case, we want a property for the currently selected product. This list component would set the property when the user selects a product, and the detail component could read the property to obtain the current selected product and display the appropriate details. Going back to the code, where should we put this property? We could create a simple property bag service to hold this property as we did in the prior module. But since we already have a state management service that tracks information about our products, let's just add it there. We'll call the property current product and define its type as an instance of iProduct or null. A vertical bar defines a TypeScript union type. A union type describes a value that can be one of several types. In this case, the type is a product or null. We want to allow null in the case that the user has not yet picked a product or just deleted the selected product. While we're thinking about it, let's modify the delete product method to ensure that the current product is set to null after the item is deleted. That way, the detail display won't show a deleted product. And let's modify the create product to set the current product to the inserted item. Then that new item will appear in the detail page after the create operation. Note that when we change a single-line fat arrow function into a multi-line function, we need to add curly braces. Now that we have the current product property, we need to set it when the user clicks on a button in the list view. Let's open the product shell list component and its template to the side. What are we trying to do here? When the user clicks one of the product buttons, the template needs to notify the component of the click event so the component can set the current product property in the service. How does the template notify the component of the click event? We bind to the click event and call a method in the component class. We'll call that method onSelected. We'll need to know which product the user selected, so let's pass that in. The product variable here is provided by the ng4 structural directive. Now, when the user clicks on one of the products, the binding catches the click event and calls the onSelected method, passing in the selected product. Now we just need that onSelected method. In the associated component, we create the onSelected method, giving it a parameter for the passed-in product. It is here that we use the service and set the current product property to the passed-in product. Now we just need the detail component to read that property and display that selected product. Let's close the product shell list and open the product shell detail component and its template to the side. Looking at the product shell detail template, all of the elements are bound to a product property. So let's define a product property in the component class. We'll set it to the current value from the product service. Do you think that will work? Nope. This line of code only executes one time when the component is first initialized. At that point in time, the current product property is most likely undefined. When the user clicks on a product and the current product property in the service is changed, this code is not picking up that change. Any idea what we may need here instead? If you set a getter, you are correct. If we replace the product property declaration with a getter, Angular's change detection will get the latest value from the service every time it's changed. The getter returns a product or null if there is no current product using the union type. Within the getter, we return the product service current product property value. Note that we don't need a setter here because this detail component never assigns a value to this property. Its bindings only read it. Let's give it a try. Here again is our list of products. Select one, and it works. Any item the user selects is displayed with details on the right. Sweet! Let's try a delete. Select Edit, Delete, confirm the delete, and it correctly disappears from the list. No product is selected, so we see no detail. That's what we wanted. Let's try an add. We'll again add a shovel, add a product code, save, and it appears on the list. Plus, it was automatically selected, so its details appear. It's all working. But wait a minute. How does this work? How is the detail component notified of changes to the current product property from the service? How does it know to redisplay with new product values? Looking back at the code, this works because of binding and Angular's built-in change detection. Let's examine that a bit more. One of the key features of Angular is its binding. We set a property in a component's class, bind it in the component's template, and it appears on the page at runtime. To display the product details, we bind to properties of the product object that is defined in the component. If we change the product object or any of its properties in the component class, those changes are immediately reflected in the page. That's when we see the effect of Angular's change detection. The change detection watches for changes to the bound property values and updates the binding when it sees any changes to those properties. Okay, we know all of this, but how does it work when the changing value is in a service? In our current APM sample application, our product service retains a current product property. Our list component sets this property when the user selects a product from the list. The detail component uses a getter to retrieve this value from the service. The product property is bound in the template, so Angular's change detection watches for changes to that property, even if that property is defined in a service. When the user selects a different product from the list of products, the list component sets the current product property in the service to the selected product. Angular's change detection picks up that the value is changed and reevaluates the bindings. The bindings call the getter, which returns the modified current product from the service, and the newly selected product's details are displayed. All of this works because the property is bound and change detection provides the change notifications. What if it wasn't bound? Is there still a way to get change notifications? Jumping back to a demo, let's change the property name so it is no longer the property bound to our template, and call our getter an ng on init, logging out the result. Looking at this code, it's only going to call the getter one time when the component is first initialized. Without the binding and change detection, our component won't be notified of changes to the service property. When the user selects a product from the list, there is no event or other notification to let us know we need to call the getter again and retrieve the current product property from the service. So, what do? One technique we can use is a timer. We can set a repeating timer, and every time the interval elapses, we can check for a new value. We'll use the timer from RxJS, which emits items periodically at a specified interval. Then we modify the code in the ng on it to use the timer. I'll paste the code and we can talk through it. The first argument to the timer is the delay. We want to start the timer immediately, so we specify 0. The second argument is the timer interval. We want to check the value every second, so we set it to 1000 milliseconds. This timer isn't observable, so we subscribe to start the timer. Every second, this code emits an item, and the function defined within the subscribed is executed. In this case, we call the getter to get the latest value of the service property and log it. Using a timer means we are not really reacting to a property change, but rather polling for a change. Let's check it out in the browser. Open the console, refresh, and we see in the console that every second our timer is logging the current product value. It's like, have you changed yet? Have you changed yet? Have you changed yet? Click a product, and the next time the timer ticks, it sees the new value of the product, and again keeps checking every second. Going back to the code, we can use this timer technique if we need a simple way for a component to check for service property changes. But note that this is only needed when that property is not used in binding. And don't forget to unsubscribe to stop the timer. There are, however, some issues with using a timer like this, and we'll talk through those when we look at guidelines later in this module. Bottom line, if we are working with bound values, we can leverage the power of Angular's change detection. Our components are then automatically notified of changes to our service properties. If the service properties are not bound in the template, we won't get notified of changes. We implemented a quick and dirty way to poll for changes using a timer. However, there is a better way. We'll see how to send explicit change notifications from our service in the next module. For now, let's undo these last code changes and allow change detection to take care of the change notifications. Checking it out in the browser, close the developer tools, and let's ensure that our app still works. Yep. Let's finish up this module with some guidelines for using the communication mechanisms covered in this module. Guidelines are helpful when evaluating communication techniques. In the last module, we built a property bag service, and in this module, we created a basic state management service. What is the difference, and when should we use which? A property bag service exposes a simple set of properties. It is often used to retain values for a component to communicate with itself, for view settings, for example, or to pass data between components, such as search criteria passed from a search page to a list page. We use a state management service to retrieve, manage, and store state values, in addition to sharing those values between our components. We used it in our demos to work with our product entity data, but we could build a state management service for any type of application data that requires management or storage. Using a state management service has several benefits. It can provide a set of methods that encapsulate access to the data store to create, read, update, or delete state values. It retains and shares state values with the components of the application. Components can use the shared data in the service instead of contacting the backend server for that data, minimizing hits to the backend server and improving performance. And Angular's change detection provides notification of any changes to state values if the properties are bound in the template. All we need to do is define a getter. But when using a basic state management service such as the one we created, we do have some considerations to keep in mind. Any data retained by the service can get stale and won't pick up changes from any other user. This may not be a problem if you are retaining data that doesn't change often, but consider expiring the data after a specific time and re-get current values. Also consider always getting fresh data before performing an edit operation. As we saw in the demos, the service does not provide explicit change notifications, so if a service property is not bound, the component is not notified of changes to that property. We'll look at this further in the next module. Also, as we have written it, our basic state management service does not enforce immutability. That means that the state values can be changed by any component with access to the service. For example, our list of products is not immutable. Once the service passes the list of products to a component, there's nothing stopping that component from adding, removing, or updating products directly in that list. We currently handle this by convention, meaning that we expect no other component to add or remove items, but we don't technically prevent it. This is okay if we are the sole developer or are working with a small team. On a larger team, or with a more complex app, we may want to enforce immutability using more complex code, or turn to a more full-featured state management library such as NGRX. So what is this magical and underutilized technique for keeping view state in sync across our components? Yep, it's a getter. We can use a getter anytime we need to keep bound data in sync. We define a property in a service, bind that property in a template, and use a getter in the component class. Angular's change detection does the rest. This technique is simple and easy to understand. However, the technique only works for bound data. What about that timer technique we saw in this module? It provides a way to poll for changes to a service property. However, a timer is often not the best approach. Set a timer interval too short, and it processes much more than needed. Set a timer interval too long, and there may be a delay between the property change and the reaction to that change. Because timers impact the timing of operations, they can cause race conditions in the application. There is a better way to get change notifications from a service, and we'll see that in the next module. In this module, we created a basic state management service. Our components use that service to share entity state, such as our list of products. We changed our user interface to display multiple concurrent components and examined how to keep view state in sync using a service property and a component getter. Then we took a closer look at change detection and how it communicates state changes. Here again is our diagram of increasingly complex techniques for managing state as a communication mechanism. In the demos in this module, we built a basic state management service. That service worked great for bound values, as change detection handles change notifications. Up next, let's see how to add explicit notifications to our state management service.